Okay, students, I just want to take a few minutes to go over inscribed angles. And as you can see, circles are a lot of fun because we can draw pigs. I can't remember what the song is, but something about little circle, big circle, something. Anyway, let's just deal with the circle. So I'll erase the pig. So we just want the circle. Here's the center. And this red line segment is a chord that happens to go through the center, so that's a diameter. Now an inscribed angle is made up of two chords with its vertex, the point, on the circle. So I have these two chords, one happens to be a diameter, making up the inscribed angle. Now we also have a central angle. The central angle, the vertex is on the center. So GPI is a central angle. GYI is an inscribed angle. So let's put some numbers on this to help us. If arc measure GI, this arc here is 40 degrees, then we remember the central angle here is equal. So we can use this to figure out the measure of angle Y here, angle GYI. So remember, the radii are congruent, so that makes this an isosceles triangle here, YPG. So that means that this angle here is congruent to this one here. The base angles of an isosceles triangle are congruent. Now by exterior angle theorem, I know they have to add up to 40 degrees, so each one must be 20 degrees. You could also think about it from the angle sum theorem of a triangle, because by supplementary angles, this angle on the inside has to be 140 degrees. So 140 degrees plus 20 is 160, plus another 20 is 180 degrees. So that's the angle, and notice it's half the arc measure. Now I know this gets confusing sometimes, trying to figure out, alright, is it half or is it double? So the arc measure is twice the inscribed angle. The inscribed angle is half the arc measure. How do you remember that? Well, think back to the central angle. The central angle is equal, right? Then just take a look at the inscribed angle. It's definitely smaller, so just remember the angle is going to be half the arc measure. It's smaller than the arc measure. So we're going to use this to help us solve some problems. Let's take a look at one other example though. If we have this inscribed angle down here in green, right here, and I know IGY, this arc, so M stands for measure, and this symbol here, it means it's an arc. If the measure of that arc, so this thing up top, IGY, is a semicircle, so it's 180 degrees, then the inscribed angle is half. So the inscribed angle of a semicircle is actually a right angle. That's 90 degrees. So these are some things that we looked at in class, and this is what you need to solve these problems. So here's an example, number 16 from 9.6. So 16 from 9.6, let's take a look. How are we going to solve this problem? Well, let's first put some points on here. S, P, U, R are the points, and we know that this symbol here means it's a 90-degree angle. But we just learned this red arc here is the intercepted arc of this 90-degree angle. Then it must be twice, so it's 180 degrees. So if that's 180 degrees, I know that's a semicircle. So there's my diameter. That also means that this angle F must be 90 degrees. And the reason for that is, if I know the red arc is 180 degrees, then I know the remaining part of the circle must also be 180 degrees. So if that arc is 180 degrees, the inscribed angle must be 90 degrees. Now we need to figure out G. Now there are a lot of different ways you can do this. This is just one way. What I'm doing is I'm looking at arc RU. And if I know this is a semicircle, then this part of it has to be 180 degrees minus 110, which is arc SR, equals 70 degrees. Well, how's that going to help me? I'm going to look at this purple arc here, this arc PUR. That has to be twice the inscribed angle here in orange. Think about it as like an ice cream cone shape. So we have the inscribed angle and its intercepted arc. The arc has to be twice that. So that's 150 degrees. So the measure of arc PU, which is just this part of it, is going to be 150 minus 70, because I'm going to take away this part here that we solved before. So that's 80 degrees. Now I can use that to find G, because I know SP is 180, which is the semicircle, minus the 80, which I just found, which was PU. So that's 100 degrees. So I hope this helps, and please let me know if you have any questions.